Hello, my name is Kevin Berry, and today I'll be presenting on finding a viable economic solution for space debris removal. Space debris is a problem because of the immense kinetic energies of objects in space traveling over 10 times the speed of a bullet. Even small objects can cause catastrophic damage, but only those greater than about 10 centimeters in size can be reliably tracked. This means that only 3% of potentially mission-ending debris can be seen or tracked. Collisions from these objects is already dominating the space object landscape, as shown in the green line here. The Iridium Cosmos collision, in particular in 2009, generated over 200,000 objects greater than 1 centimeter in size. Despite these potential risks, space debris is not a clear and present danger. The collision cascade predicted by Kessler is fundamentally true, but it's on the order of decades. And currently, even the most populous orbits in low Earth orbit have only a cumulative percent chance of collision with a greater than 1 centimeter object of less than 1%. The NASA Legend model used to predict these collision rates was developed in 1997 and serves as the basis of international mitigation policy. This same model, when introduced to 6,700 additional satellites, increases the number of collisions from 27 to over 582. SpaceX alone plans to contribute 12 to 42,000 additional satellites in orbit, a 1,400% increase over the tracked objects. The assumptions made in the NASA Legend model are far too optimistic and undervalue this exponential risk. Even without collision, space debris is imposing a shadow tax on all users because the launch window restrictions require a margin of safety and had to be changed from a 25-kilometer exclusion zone to a probabilistic shape similar to a blimp. Continued congestion in orbit will make it increasingly difficult to merge safely into space lanes. Even if these mitigation efforts are insufficient, there are significant barriers to fixing it via active debris removal. The regime under the Outer Space Treaty hosts that all liability for space objects remains with the launching state, whether they are launched privately or if that object is damaged and breaks up in orbit or during re-entry. This makes it very difficult to achieve without permission from the launching states, and at present the top 100 most dangerous objects in low Earth orbit are not under the control of the United States. As of yet, no nation has technically demonstrated or proven an ability to safely remove debris from orbit, and as such the economic cost estimates are high and have no proven market value to date. EDI and Astroscale are both actively working to change this, but are as of yet speculative. The sentiment is perhaps the greatest barrier to fixing this problem, however, because it is not viewed as a problem. It is seen as an insurable, if not ignorable, risk. In order to understand how rational actors can naturally produce inferior results, two metaphors are commonly used. Tragedy of the Commons, which describes a wide open field of grass where cattle herders can bring as many cows as they can to maximize their personal utility. But when every herder brings as many cows as they can, the commons are quickly overrun, leading to starvation and tragedy in the commons. The second is the prisoner's dilemma, in which prisoners are given a binary choice of cooperating or defecting with their compatriot. By defecting, they maximize their personal utility, even though by working together, they would achieve an overall better result. The inevitability of these scenarios is challenged by Elinor Ostrom, who uses significant empirical data to show that this is not how it always happens. The purpose of this presentation is to understand how and why some groups are able to resist temptations and act in the interest of the group as we apply it to the global space commons. In order to characterize these models, 4 tools are used, in particular the pyramid-shaped preservation model, which represents the increasing cost, complexity, and support required to economically viable approaches preserving the commons. Stakeholder diversity and scale reflects the complexity of the problem. For example, cattle herders arguing about how to use the commons generally have the same values and goals in mind. But if a herder, a farmer, and a real estate developer wanted to use those same commons, they would have different values and goals. Stakeholder responsibility assesses how much overlap there is between blameworthy parties and the affected parties. And lastly, the metric understanding changes to the dilemma. Look at how the incentives have changed from seeking personal benefit to maximizing group utility. The first case study looks at debris terrestrially and finds that hidden problems get worse because of human complacency and not having to confront the issue. Debris on land is fairly easy to see and to address, and therefore, with a change in mindset, significant progress was made. In fact, remediation can be done without the pyramid, but it comes at great cost, as was shown in Rwanda. Ocean dumping, on the other hand, suffers from a lack of clarity on the depth of scope and the increased challenges of diversity and scale posed in the global oceans, meaning there have been no significant, meaningful changes. Public solutions to these complicated problems are economically inefficient, and market solutions are preferable if the conditions are right. However, in order to compel action, there has to be marginal benefit greater than the cost of action. Lighthouses and salvage operations represent two such cases. Ostrom explores in her traditional agricultural models the 8 effective design principles for stable preservation of the commons. In particular importance, these systems were stable because they balanced incentives to produce things more like you cut, I pick scenarios to maximize the mutual benefit. And they utilized informal and easy conflict resolution combined with strict and graduated sanctions with clear boundaries to allow for the development of deep social networks and trust to form without causing damage to the environments they operated in. Fishing is much more complicated than these agricultural models, however, as it suffers from hidden information, moving populations, and rapid technological advancement. And it shows us that the commons are not one smooth field, and not all fishing spots are equal. Canada exemplifies this failure because they tried to govern their fisheries under the assumption that they behaved more or less the same across all areas, and this led to a moratorium on all fishing of northern cod in 2002. Industry can be an effective means of responding to these major problems, but it requires a significant forcing to act. The issue of chlorofluorocarbon emission that damaged the ozone is a great success story in this regard because it had a well-supported network under significant pressure. However, the Deepwater Horizon oil spill is a cautionary tale about the dangers of treating a solved problem with complacency and not testing remediation measures before catastrophic events occur. The orbital environment is not on a good trajectory as the public commons. Even with the 25-year post-mission disposal guidelines in place, in the last decade, only 25% of satellites that weren't naturally compliant even attempted to comply, and only 5 to 15% of those were successful. Total funding for space sustainability in the US including tracking, is in the tens of millions of dollars, compared to the $15.4 billion budgeted towards Space Force. All the scenarios analyzed in this presentation are based on the assumption of natural debris creation alone, but if this funding leads to further ASAT or orbital hostility, it would be devastating, as we do not have measures in place to adequately deal with that problem. In seeking to find a viable economic solution for space debris, the best solution is to avoid the problem in the first place. If that is not possible, then building the pyramid of preservation is the most efficient means to achieve preservation of the commons. Hidden problems like ocean debris highlight the need for more observation and identification. Market solutions like lighthouses demonstrate how commerce can be utilized to efficiently deal with the problem. Long-term agricultural practices show how social networks are cheap and effective. And fishing demonstrates how the commons are not uniform, and we need to treat them with the niche understanding that industrial regulation could provide given significant pressure. The tragedy of the commons is not an inevitable in orbit. By focusing on building the pyramid from the ground up, we can preserve the commons for the benefit of all humankind. Thank you.